Good morning and welcome to the Problem Solving Penguarium, where we learn how to solve problems better. Today in episode 2 we will be doing a Year 8 science-based questions, and we will be stepping our way through it using, of course, Chucky and the strategies of clarify, choose, use, check and conclude. So if we don't understand clarify, choose, use, check, conclude, go and check out episode 1. So first step, without fail, every time, clarify the question. Weight N equals mass kg multiplied by acceleration due to gravity m/s squared, which is meters per second squared. We don't need to understand everything in that sentence. We just have to be able to translate that into maths. So let's have a look. Weight equals mass multiplied by acceleration. We can do that. Weight equals mass multiplied by acceleration. That's all we need at this stage. Acceleration due to gravity on Earth at sea level is approximately 9.8 meters per second. Important. Acceleration due to gravity on the surface of the Moon is approximately 1.6 meters per second squared. An object has a mass of 10 kilos. What is the difference? The difference, that's important, I need to remember that, in the object's weight on the Moon compared to its weight at sea level. So, looking at the words, we've translated it into maths. If I have numbers and I have a mathematical equation, 9 times out of 10 I'm going to be able to solve something. So let's see what we have. We have our equation, W equals ma. The mass we have, m equals 10. The w, we don't know, that's what we need to work out. And the acceleration, well, we have 2. We have the acceleration of the Earth and the acceleration of the Moon. Not the Moon, the Moon, there we go. So the acceleration of the Earth is 9.8 meters per second squared. Again, we don't need to know that, we've just got to recognize that it is the acceleration due to gravity, which links into our equation up there. And acceleration on the Moon is 1.6 meters per second squared. So let's work out what the weight would be on Earth first. So choosing a strategy. Well, we can do our simple mathematics. We have translated it into maths and we're just going to substitute into an equation. Using is the bit I'm up to now. Earth. Okay, write my formula because that's what I always do as a good mathematician or scientist. Substitute, and W stays as Wm, becomes 10 times acceleration due to gravity on Earth, 9.8. So 10 times 9.8, I move the decimal place once to the right because I'm multiplying by a factor of 10, would be 98. Now if I wanted to be specific, I would include the units as well, even if I didn't know what they meant. So Earth, the weight on Earth, based on the information we have, is 98 newtons. Now we're going to repeat the process for the acceleration on the Moon. So Moon, weight equals mass times acceleration. W equals, the mass doesn't change, 10 times 1.6. Move the decimal place once to the right because I'm multiplying by a factor of 10, would be 16 newtons. Okay, check. Can I check my work? I can check it on a calculator. I can do the multiplications again, but I am 100% confident that when I multiply by 10, I move the decimal place once to the right. Okay, now the next thing, it says the difference. What is the difference in the objects? The difference is another way for subtraction. So my answer, if I look at my choices, it's not going to be 98 because that isn't the difference. That is just Earth. It's not going to be 16 because that is the Moon itself. So it immediately has to be either A or C. So let's work out the difference on the Moon compared to its weight at sea level on the Earth. So let's do the difference. Okay, 98 minus 16 equals, we'll do it over here properly, 8 minus 6 is 2, 9 minus 1 is 8, leaving me with 82. Is that one of my options? Huzzah, yes it is, it's C. 82 or 8.2? Well, we've checked it. It's definitely not going to be 8.2 because that is less than half, just over half of the moon's weight. So I'm 100% confident that it is going to be C, 82. Have we checked our work? I'm checking my sums. I'm happy with that. I'm happy with my sums. It seems to fit. Does it make sense? Well, yes, it's the difference. And conclude. Now this is a multiple choice question, so our conclusion is just obviously circling the correct answer. However, if we were to conclude in sentence form, as we were asked the question in sentence form, we'd say something along the lines of, and I'll just type it in, the difference in weight, the difference in an object's weight between the moon and the Earth is the difference in an object's weight between the moon and the Earth is 82 newtons. Now we need to clarify the mass because we do know the mass is 10 kilos. So the difference in an object with a weight of 10 kilos between the moon and the Earth is 82 newtons. So I have clarified, I have chosen an appropriate strategy, I have used it and checked it, and I have concluded.